Do you like engines? Do you like to talk about engines? Then you're at the right place. From Engines 101 to practices that can help you in your machine shop. Welcome to the Engine Professional Podcast.
Well, Chuck, here we go again. Another month gone by. I don't know about you. I noticed April we had a lot of virtual shop tours. I saw lots of stuff on social media in April. A lot of member shops are being highlighted. Man, there are some really cool shops out there as far as equipment and layout. And I don't know what it was. A lot of virtual stuff coming out, but it's nice to see all our member shops as much highlight as they get for virtual tours like that. What did you think?
Yeah, that's fact. It was funny having the conversation with Chris last night, and he pointed out, he's like, wow, we got he goes, Rottler's doing those shop profiles videos, and he's like, and look at the AERA members that have been shown just recently. Chode Engineering Performance and Baldwin and Corey Schlegelmilch, of course, and Corey's involved in some other stuff with us that's showing off his shop. So that's really super cool.
It is. It's nice. I mean, I know you and I get to go out, and every now and then when we're out doing a regional or something like that, we get to actually physically visit the shops. But when you can do a virtual shop tour and just see what other folks have out there, and I've said this before, that the power of social media and to be able to highlight your shop like that goes a long way, even for, folks that are looking to maybe put in a resume there or apply there. I mean, to actually see physically where it is and what's going on in the equipment that you could possibly have to run. It's a powerful tool that works really, really well.
That's a fact. We all know there are some downsides to it. There's no denying that, but there's a lot of positives. So, everybody knows that I was in the military, and I keep in touch with people around the globe that I became friends with. There's, like I say, the negative things, there's going to be some bad posts and stuff, but by and large, I mean, it's a great tool to, get a glimpse inside of what's really going on in an industry maybe that you don't know about. There's a great learning opportunity. So, you can pick out the bad stuff and discard it and use it for good.
You can. And with today's smartphones and everything, it's just so easy for anybody to be able to just basically post a video of your shop or to highlight yourself. I mean, with the Facebook platforms and Instagram platforms and the way your phone works, I mean, really, you do not need to be a video expert anymore. Like, back in the day, you can literally post a lot of this stuff and do these little snippets yourself. So they've made it very easy.
True.
Yep. So speaking of shops, Chuck, April settled down for us just a little bit. It wasn't quite as busy in April because I know we got lots of stuff coming up in May. But I know you were out at Maine Automotive and you did a custom training event up there. And how did that go?
That went great. Every time I go out and do one of these, they, of course, they introduce me to some people that I've only talked to on the phone. And then when you shake hands and meet face to face, it only improves, your communication, your relationship. But, when my opportunity to go out there, I worked with a couple of gentlemen that, they have some machining background, but not necessarily engine stuff. So we get to work on some stuff in-house there. The guys at Maine Automotive are always, I've been there before, and there's not particularly these two guys, but Chance and his team out there. I've got to know several of the folks, Glenn Pappas, and they have 3 stores in Oklahoma, and they got a big outreach. So, they have one machine shop, but 3 different stores that they, drive everything back to that one location. Of course, it's the oil patch, right? So they make all kinds of hoses and lines. They do hard lines. They do hydraulic tubes or hoses and so forth. So pretty interesting shop. And one of the things that I got to say about typically when you go to a shop that's got a parts store, they're really super clean, well lit. I think because they're so used to promoting themselves, right? Being a parts store. So they got to look the part. So they usually do a really nice job of keeping their shops really clean. and they let their customers go in and show it off. So they do a lot of good things there. So I was, happy to be a part of it. Again, every time I go out to teach, I learn and I come back with homework. So it's a great thing to be a part of. I know we talked about it in the last podcast a little bit, yeah, but it's a great thing to be a part of.
Yeah, it's a cool program for members to be able to have you come out there, to come right to the shop and take part in helping them with training or a new hire or a piece of equipment, that kind of stuff. Yeah, it is a cool program, and like I say, if you want any more information about that, you can go right to our website. There is our custom training. There's a tab on there for custom training. So if you or want to get a hold of Chuck and talk more about it, he's setting his schedule for 2025 already, but if you have any kind of custom training that you want him to come to the shop, by all means, just like I say, Chuck, then get a hold of you and you can kind of take it from there. Other stuff that we had on the go, kind of a cool program. It's Viewpoint with Dennis Quaid. And actually, when you spoke about Corey Shigelmelch's shop out in Nebraska, we actually filmed there for the day, and kind of stay tuned. That's coming to public television here pretty quick. We're going to have dates coming up, and there's more to come on this. But we're looking to educate more about engine rebuilding and the future of engine machinists using Dennis Quaid's platform with Viewpoint. So, Chuck, that's a pretty powerful message and a pretty powerful tool to get our message out there.
Absolutely. I actually didn't know that Dennis Quaid was kind of into that segment of the market until I listened to a Mike Rowe podcast, and he and Mike Rowe were talking about, because Mike Rowe Works has that, they're trying to draw people into the trades, right? And so to hear that Dennis Quaid's got some of that same motivation and wants to draw people to the trades and highlight that. And both of these people, they don't come from the trades, but they recognize the need and they have the resources to reach people and express that need. So yeah, that's very cool. And to be a part of that, yeah, you couldn't ask for anything better for us as a trade association to help market ourselves. It's great. Hands are needed. Hands
It,
are needed.
exactly. So, like I say, we'll be posting and doing lots of stuff on our socials. That'll be on our webpage. So as soon as we know that date that'll be out on public television, we'll be able to release that and get that out there for everybody. Other stuff that we've been working on. So good news, we're going to be doing our ERF fundraiser again for a big block Chevy engine that we're going to give away at PRI. And I know parts and pieces are coming together for that one. They've got dart block and heads. They've got a scat crankshaft. It's going to be another really cool engine that Baldwin Racing Engines is doing for us. So that's coming, Chuck. Again, we're going to have that engine sitting in our booth. It's always a good looking engine, and the money from that goes to grants and scholarships to help train and educate machinists. So you don't need to be a member to take advantage of these scholarships. So I know you and I talk about this all the time, Chuck. It's free money sitting there for people to use, to educate and to train. So that's what the money goes for from this engine sale.
Yeah, just to go back to the bit we were talking about prior, with Dennis Quaid and Mike Rowe and stuff. These scholarships, there's great opportunities out there, and again, we're happy to be a part of it. So, continuing education, get out there, reach out to us, and let us help you help yourself.
Correct, and you don't even need to be a member. I mean, we do have scholarships for non-members. The grants are also for members, but maybe you've got a new hire in the shop, and that new hire would like to take a course on welding or something related to be able to help you in the shop. That's why that money is there. So by all means, take advantage of that. I know when I had my shop, we took advantage of ERF funds to be able to send a machinist down to the Mondello School. I mean, I know we're dating ourselves a little bit, but that Mondello School for our shop was involved in porting and that sort of thing. And I wanted to have one of the best teach our employees. So that's what that money's there for. So again, if you go to our website, you can read all the information about the engine build as well as those grants and scholarships. So take advantage of that money. That's all I can say. It's there for you.
Yeah,
And
very
check.
cool.
Exactly. And in May, we got a couple other cool things going on. We've got two regionals in May coming up. So the first one is actually out in the Netherlands. It's out in Amsterdam, and that's at FTF Machines. So for those folks that are listening that are kind of in that area, Steve and I will be out there and looking forward to seeing everybody for that one. And that'll be on May 2nd and 3rd. Then we've got Goodson and Edmonton. So Edmonton, Alberta, Canada, that's going to be June 7th. And then Goodson will be June 20th. So I've got some pretty cool events coming up here in the next little bit for sure.
Yeah, there've been a lot of things going on this year already. We usually uh, plan for a heavy fall, but yeah, we've been busy this year. It's good.
It is, and it's good to see that we're sort of spreading our wings a little bit. Doing some international stuff. Like I say, we're hitting up. We're going to do our own event out in Canada, and then we're collaborating with FTF out in Netherlands. So again, looking forward to seeing everybody out there. So Chuck, we take a lot of calls on the tech line, and one of those components that seems to get overlooked a little bit is valve springs, and I know they play a really important role in the engine. And I think sometimes we, again, just take them for granted. We kind of just think that they're, you know what, if they hold pressure, it's good enough, right? So I know you've got a pretty cool little presentation for us today that you put together, and I think we're going to know a lot more about valve springs by the time we're finished talking to you, by the time we're done. So
Right. So we won't get too far into the weeds, but we'll try to give you some more information that can help you understand the importance of springs because they are one of those things. I mean, the valve train's not going to work without them. And there are some cautions that you definitely want to be aware of before you choose to reuse springs more than just does it meet pressure. So anyway, with that, I will go ahead and start to share this slideshow.
yeah, I know that, like you said, they play an important role, and yeah, we can see your slideshow there. So it, I'll just try and follow along, Chuck, and yeah, if I got any questions, but yeah, it looks good there for sure.
All right, great. So, kind of the basic spring layout here. Of course, a spring has to be retained, right? So, it's a working component with the valve, the retainer, the valve locks. So, and what the spring is doing is basically going to pull the seat or the valve back to the seat after you have a breathing event, whether it's inhale or exhale. So the camshaft, of course, times all of that. But some of the key measurement areas that you're going to be looking for are, of course, the installed height, um, the closed height, which is going to be, once you have max valve lift, and then your distance for coil bind. You need to know like inside diameter, outside diameter. Is it going to fit into the spring pocket area? So those are some of the features and dimensions that we would have located on process. Like if you're looking for you get cylinder head specs, most of this stuff is going to be listed throughout the head, the cam, those dimensions so that you can qualify that when you're working.
And and Chuck, just to clarify, so valve spring height is different than valve stem height, correct?
Absolutely. Yeah, that's a very good question because when you're at the machine cutting the valve seat, it's going to have an impact on all those dimensions. But what's the easiest thing to measure? Of course, it's going to be easier to measure with a tube and measure the valve stem height than it is going to be the install the retainer, some kind of measuring device. They have calipers or they have like some micrometers that you put between the retainer. You got to put the valve locks in. So it's quite an arduous process uh, to get that dimension. So what we typically do is try to come up with an installed stem height just to make it easier. But again, that all relates back to the installed spring height. So I need to know those pressures. So it's oftentimes we do get that question. I just took it last week, from someone who is a bit more of a novice in the machine shop. So what's the difference here? So, cylinder heads are the first things to come off. So they're the first things that we need to learn about primarily.
Cool.
So some common spring designs. Of course, you know, it, if you can see this well enough, and I know some of you folks are listening at home or driving down the road or whatever, and you're working and you're not actually seeing this. So when you get a chance, do please watch the video version so you can see some of this stuff. But common springs are, the early ones were round wire. They had a flat damper on the inside. Sometimes they have an external damper, which is basically kind of like a basket that the valve spring sits in. And when you get into more of the performance applications, they will have double springs. And so they do multiple things that helps control harmonics and keep the spring straight, but it also can give you higher forces if needed, when you're using a double or a triple spring for a high performance application. That flat wire damper thing that's inside of the springs, that's again really to stabilize the spring and kind of help resist some of the vibration, with harmonics. And if you get stuff out of control, like the vibration in a crankshaft, vibration through any part in the engine, if it becomes to the point where it gets unhappy, things break. So that's the intention of some of those things that are in the spring. So, that's why is that there? Don't just throw it away. You may not have good results afterwards. Progressive wound springs. If you've ever seen springs that have a tighter group of coils at the bottom than they do at the top, that tighter grouping of coils is nearly always down toward the spring pad or the spring seat area. I can't think of any applications where it would be opposite of that, but I'm not going to say there aren't. I actually have a spring that I'm going to show you later. I'll put it in front of the camera that I don't even know the application, but it's, there's some really crazy spring designs out there. It's the earliest version of variable frequency springs. When the ones that are set closer together, they're going to touch, and then that changes the spring rate. So most of the time, the wire itself, you'll have a pretty much linear rate if you have a round wire that, it is pretty stable. So you have a round wire, a common dimension kind of spring, so that you can kind of predict based on the material that the spring is made of and the rotation and the pitch and all the things that the engineer into the spring, then it's got a pretty linear rate. So you can say, okay, at this lift, it's going to be this, and at this lift, it's going to be this. Once you start changing the ID to OD dimensions, or you add extra coils at one end or the other, then you can get variable rates so that it, as I get closer to a higher lift, it may not bring on a huge over the nose load that can be undesirable and wear cams out. So anyway, there's just some of the reasonings for a progressive round spring.
And Chuck, what happens when you accidentally turn those the other way? What could members look for there? What would be the failure?
Well, now I have more weight up on the higher inertial end, because all of those coils stacked together is going to be, as it's closer to the retainer. So that's more inertial weight that's being traveling that you got to control, right? So that may rebound into the push rod and the rocker arm and the lifter. So that could be some of the negative effect. If you get to looking in the performance world, they start trying to take weight out of that reciprocating mass, just like a piston and a rod assembly or something. You start taking weight out of that, and that's to your advantage. So if you get those upside down and you increase the weight on that end, again, that can be detrimental. Maybe it acts like an overspeed situation and you break a retainer. The keepers pull through the retainer. Again, mass can be your friend and it can be your enemy. So Hope that answers it.
Cool.
So the beehive is a very common spring design today. Now, beehive is shaped just like kind of like a hornet's nest. That's where they come up with that little moniker for it. It can be round wire or it can be ovate wire. Again, so we know we have folks that are listening out there only. So when we talk about ovate wire, what that would look like if you were to cross section the wire, you're going to find that the axial height, so that would be like your vertical dimension, is different than your radial dimension. So radial would be from the ID to the OD, and axial would be, that vertical dimension, top to bottom. And what that does is gives you a variable rate of spring. Now it requires some very special uh, coiling devices, to keep that stuff tracking right, or else you get some undesirable twist in it. And then, of course, that's going to cause a failure. So they are a bit harder to manufacture when you're using the ovate wire, but there's a lot of benefits where you don't have to have crazy high seat pressure, but you can get the opening pressures that you need. And again, most modern engines have something in that range.
I know
That
I took a call once, Chuck. I think they pulled the beehive springs out of the box and they were really, really crooked. They were concerned whether the beehive spring needed to be straight or not. Is that is that an issue with the spring being, you know?
Yeah, if they're coiled where that they get kind of, I've seen that before where it looks like it's almost flat to one side. And that's not going to be good because it's going to put undue pressure as it tries to center itself, because the valve's going to, and most of the time you have a valve stem seal that has a pilot on the bottom, right? So you got top hat stem seals, because most everything's aluminum today, or the cylinder heads are aluminum castings. So if you have an aluminum casting, you have to have something on the bottom that's going to pilot the spring as a wear surface, because if you just put in, and I've seen this happen, from forgetting to install the stuff, coming from a production and machine engine shop, where they didn't put the shim under the valve spring and it chews right through the head. Doesn't take very long to do it. It happens pretty fast. So you have to have that hardened pilot under the spring and then the retainer and this stuff up at the top. So it's going to try to make itself aligned in some fashion. So you could, exaggerate valve guide wear simply because of that situation. So I would say err on the side of caution and reject the part.
Okay.
You know, another thing to mention about the beehive, going back to the mass, if you take a look at the size of the retainer with a beehive spring, of course, hey, it's much smaller up at the top. Well, what's my benefit there? Well, I'm going to be reducing mass once again. So if I can take away that inertial mass, especially at higher RPMs, then it's easier for the valve train to stay happy, you know. Uh, and if, like, many times what happens is the valve train components don't really follow the pattern of the camshaft. So if you can get more of these things under the control when you design a cam, then you can expect that the valve is going to act as if what the cam's telling it to do.
And speaking of that, I mean, Chuck, you could probably attest to this, is valve spring specs are crucial to cam specs, if I'm not mistaken. Is that correct?
Oh, for sure. 100%. Because the what they've really tried to do over time, used to, it was like, if you got enough spring pressure, you can do kind of whatever you want. You just got to be able to keep it from lofting really bad. And some of the lofting stuff is predicted and accepted, but you need to keep it under control. It needs to be engineered into it. But with these modern springs, they are definitely allowing us to get better performance out of smaller cams per se. So all of the numbers that we typically used to look at, I want big lift, I want big duration, blah, blah, blah. You're finding that, hey, if I can keep this stuff in concert and very well controlled, I don't need quite the big numbers that I used to have. So that, if again, by reducing that reciprocating mass that's out there, uh, by getting stuff to track better, got better surface finish control for rollers, and, too slicks can be a problem, too rough can be a problem. So yeah, it's a very, it's probably one of the most dynamic parts of quite an orchestra. It all has to be playing very well together. Uh, but
There's some YouTube videos, out there about valve springs in motion, at high RPM, and they've got with slow motion cameras, they've really been able to, slow the film down and the video down. And when you look at that stuff, when you say concert, I mean, we're talking heavy metal, rock and roll headbanging concert, because those springs are doing they're just bouncing and they're giving her all over the place. I mean, if anybody's watching, like I say, just YouTube, valve spring motion or anything like that, you'll see that video I'm talking about.
EFI University, they've got actually, I've got a video I should have dropped in here, but maybe we can put that out there for some, maybe Friday failure or something of that nature.
Exactly.
Let's just put it out there in social media land.
There's a lot going on. That poor valve spring it's got a big job to fill for sure.
That's a fact. And going on that just a little bit, sometimes I think when they get totally out of control, so you have valve float, you get a situation where the weight of the valve head is such that you're not going to pull it back to the seat, and you'll get a situation where if you were to visualize taking a basketball and bouncing it between maybe a bench and the floor, you just get this. That's what's happening with the spring. It just kind of gets close to almost to the solid height, and now it's just bouncing between the retainer and the spring seat. It's just so out of control. It looks like it just stops in that position. Yeah, it gets really ugly. So again,
Yep.
The details matter.
Right.
So moving on, we got a conical spring application here. Again, this is a fairly common design you see now. As I change the ID to OD dimension, as the radius changes, it's going to impact the rate. So if you can imagine, even if you're not an engine person, you're a chassis guy and you know how a torsion bar works. Well, that's what's going on with a valve spring. So as I change the radius, it means that every single coil has a slightly different torsional effect. So you can use these to your advantage at different speeds and frequencies. So, once you kind of upset something that's super rhythmic by having those, then you have bigger bands of area where the spring is going to be safe to not set up in some hysteria and break on you. So yeah, it's a great way to get around this. These are not as frequently seen in the real high performance stuff that I've seen as either like the beehive or multi-spring round wire applications, or ovate wire. This is more of kind of what you would see for variable frequency, kind of more in the OE class is kind of what I would say here. So I'm sharing a slide here that's just got a bunch of materials. This has changed quite a bit over the years. Grades like music or piano wire alloys, some of the very earliest. You have oil tempered high carbon steels, chrome vanadium. It's a little funny story about going back to Henry Ford. He used a lot of chrome vanadium in the Model Ts. It's like they had done some testing and they found out that it performed well in a couple areas. So he just kind of, chrome vanadium this and chrome vanadium that. So that's definitely an older alloy. Chrome silicon. So again, if you get a chance to watch this rather than just listen, then you can check out these slides. But there's some good data here. And also we have most of all this data is in a couple articles that we have in the Engine Professional magazine. So we've got quarter 1 of 22 and quarter 2 of 22. So when Fernando Carrello used to be on the tech line with us, he has a great amount of experience with valve train stuff, and he wrote a couple of very good articles on valve springs for us.
And Chuck, how important is it to, like a lot of times when you're buying aftermarket springs for maybe, from an aftermarket company, how important is it to match retainers to the spring?
It's quite important to make sure. I mean, it's nice to have, especially in the performance stuff, Rob. To have kind of a snap fit because of the more movement you have, like you said, that hysteria of everything that's going on when you have high RPM. Uh, but it is good. You don't want to have so much that you potentially deflect and cause a fracture or failure, but you want to keep the stuff well located. So it is good to match. And then, you have to ask yourself, what are you building and how much do you want to check and measure? So that's everything has tolerances. Everything has a range of what's acceptable. You also have what your expectations are. So you may have to buy a box of springs to get yourself dialed in exactly where you want to be. The cup guys and so forth, they do some really, really in-depth analysis of the springs to make sure that they're where they want to be, but they're sustained high RPM for hours on end, right? So you have to really evaluate what you intend to do with the engine. And then, hey, am I going to measure my loads with the retainer when I'm testing the springs and so forth? And say, I want to have everything that's going to potentially cause the distortion and will give me some kind of feedback, meaning, okay, I'm going to see a pressure differential or something. So yeah, definitely in performance world, it's going to be a lot more critical than just, stock street stuff.
Okay. All right.
So every valve spring is shot peened. Now, some are even further post-processed, like vibratory polishing. Everyone's heard of rim polishing. But what that is there's inherent stresses created by the rolling process. Again, we talked about springs are made like a torsion bar. Now, shot peening also induces skin layer stresses, surface tension stresses. But when it's very engineered, organized, and structured, it can reduce inherent stresses that have been induced by rolling and create surface layer fatigue strength stresses. So no different than when we heat treat. So, I mean, we heat treat for reasons. Say I take a particular steel and I'm going to make a crankshaft out of it. And then I induction harden the fillets, and then maybe I nitride the journal surface. So I have a crankshaft that I still want to have a lot of flexibility, because a crankshaft is much like a spring. I have a cylinder that's under compression that's slowing down, and I have a cylinder that fired that accelerating. So what's that doing to a crankshaft? It's trying to twist it apart, right? And then if you look at how the crankshaft is manufactured, from the mains to the rods, I have throws, and you have counterweight. So as I have cylinder pressure, it actually tries to push the, the this. I have to overcome the cylinder pressure, so it's pushing the crank apart. So actually, your crankshaft is growing from the front to the rear because the arms between the pin and the mains are pushing outward. So I have a twisting torsional effect, and I have that expansion of growth in length and contracting. So valve springs see a lot of those twisting torsional loads as well. So you see shot peening on crankshaft radiuses, induction hardened radiuses. And then like the nitriding gives you a hardened, slippery surface, to slide for the journal. So you're doing some of the same things here, like the REM. Any scratch, nick, burr, flaw, that's what causes the valve strings to break as they're cycled. So that's why you also can't get valve springs that are, have a part number on them. So anything you were to do to that spring to identify the manufacturer, date code, so forth, it's likely going to cause it to break. So that's kind of a downside. And I've been through this in the past. So where we pushed suppliers to paint stripe valve springs, because that's the only way we could tell supplier A, B, and C from one another.
What's your thought, Chuck, on like U-Springs media blasting then? Like what's your take on that?
So if you're soda blasting, if you're plastic media blasting walnut holes and so forth, they're not going to have the shot intensity that they're going to do anything negative or positive. Now, you could throw them in your steel shot blaster and potentially harm them. And I got a slide coming up that can show you why that is the case. But yeah, I mean, some of the non-aggressive methods are not going to do anything negative to it. Now, one thing I would do is make sure that your springs are not rusty prior to any kind of media blasting, because rusting will, as it starts to, it's like tooth decay, as it makes a pit in the surface of the spring. That's probably a good propagation point for a failure. And if you cover that up by just shot blasting it with soda or whatever your method is, you're not doing anything to help take care of that. So now, again, you want to qualify them before you just go and blast them and make them look pretty.
Okay. Yep.
And so moving on here, shot peening of springs. And actually, this data right here is actually any kind of shot peening process. So shot peening imparts changes in surface finish and texture. It relieves stress created by forming methods such as seams and roll marks, and it creates compressive stress at the surface, which improves fatigue strength. So just saying what I said a couple slides ago. But if you take a look, you're going to see what is called an almond strip. An almond strip is a carbon steel kind of little platen that's to a certain, to a specific dimension. It's going to be, thickness, hardness, width, length. And then what you would do is machine out, like if you're doing a crankshaft, you take the crankshaft that you intend to do on a production basis, and you notch out an area, say in the press radius, and then you mount this almond strip, and then you test your blasting operation, and it will change the arc of that almond strip. And then there's a calibrated device that you would use, or that you use to test how much deflection you've had from your shot blast. And then once you have proved or disproved, how much deflection you're looking for, then this, you can check your work as you go. So oftentimes what people do is save that same crankshaft and go in there, because it's about checking your shot intensity. But things that also impact the desired surface finish are the shapes of the shot. So if you have nice round shot balls, or if they're uniformly ovate, they're good. Even if you have some shot balls that are kind of stuck, they look like they're, Siamese and almost stuck together. As long as all the surfaces are nice and round, then they're good to go. Undesirable shapes are like something that would be a sharp shard. So sharp edges like a half moon or a quarter moon. As you can see, anything kind of rectangular, I see like a polygonal shape, or something that looks like a meteor or coral. If it's got any sharp edges, then they can create undesirable stress risers. So again, a point of propagation for a failure. So anyway, if interested in this, there's a ton of information out there about this. I actually like this subject. For me, I like the heat treating and metallurgy, and kind of the stress of materials and surface finishes. That's the stuff that I really enjoy a lot. But there's a lot to be said about the like shop painting. So and so what does this all matter? So it's to ensure long life of parts, to ensure that parts can perform at various RPM ranges, and ensure that springs don't break and drop valves into cylinders and destroy engines, right? So here's some cross section and mount of a broken spring. So you can see this one. Uh, this was actually a hydrogen embrittlement thing in the top, where it broke a lot of different places. And then the one on the bottom, you can see a wire anomaly here and a fracture surface point. So I just, I dropped a couple of different things in there to kind of look at. So if you were to take a look at that, you may have not been able to see that by the naked eye anyway. If you covered it up, say if that little spot there was rust, and I covered it up just by my cleaning process, who knows now? You get failure back and you're just scratching your head. Hey, it's broken. Why? So again, I'll go back to just make sure that you test your springs, especially if they got rust, discard them. It's just too risky.
So visual testing is pretty important. I mean, obviously pressure testing is important, but that visual test or visual inspection is also very, very important.
Very, very important.
Mm-hmm.
So that's about it for the slides, and I'll stop sharing here because I got a couple of things that I can show otherwise.
So a lot going on, and again, valve springs. I know sometimes they get taken for granted. You think we're disassembling. There's no rust. They seem to pressure good. We've gone 150,000 miles on these springs, but when you think about how many cycles and the pounding and everything they've gone through, it's one of those items that again might be overlooked, but you might want to consider replacing because they have a really important job.
Right. And think about where they're located too. When they heat cycle, so they're usually under the valve cover sheds the heat really fast. And what happens to stuff that sheds heat a lot? Then you get a lot more of the condensation and so forth. So they do have a tough life. And so that range of cycling of load and so forth. But yeah, they are in kind of a bad area too. I mean, you've noticed when you've torn cylinder heads down how ugly they can be sometimes. So
and it's one of those things too, especially with these newer engines. We talked about valve stem heights and valve spring heights and whether that measurement is with the top hat seal or the valve seal in place. Again, we can't emphasize enough how important it is to take a few of these measurements beforehand, before machining, because, a lot of times, especially with some of this, especially the German stuff, Mercedes, that kind of thing, getting actual valve spring pressures and that kind of information from them is nearly impossible. So if you can get pre-measured beforehand to kind of get yourself a head start before you assemble, it sure goes a long way to help help yourself out.
That's a fact. Actually, I just listened to podcast with Miles, and he was talking to Mark Malberg, and he was referring to This Old House, and yeah, I really like that show, and that whole measure twice and cut once thing. Whether you're building houses or building engines, a few extra measurements can probably save you a lot of headaches in the long run.
Exactly. Yep. And I know, just again, we have a lot of information at our fingertips with AERA and all the service manuals and with Process Pro, but sometimes that information is just not there. So, we rely on members to help measure that stuff so that we can have a reported spec. But again, we can't emphasize just please, measure before you machine. That's such an important rule to keep in mind.
That's fact. And
Yep.
here, as I started out, I said I had an odd spring that I don't even know the application for, but this came from SBI, and so it shows a couple of things. One, I mentioned the paint color to help identify who supplied it. So you'll see things like that. Now the OEs have done some of the same as well. You'll see the dicom of different colors on some OE springs. But in the aftermarket, when you're seeing that, that's usually an indicator. Okay, it's this company, that company. Uh, but look at this guy. Now it's a variable rate spring. Again, I don't know the application, but this I've seen like some clock springs and stuff like that. But I'm pretty sure SBI doesn't sell clock springs. So
Yeah, it's almost barrel shaped. It looks like a keg. Like a keg of beer. That's kind of the look to it. So
exactly,
so with that paint stripe there, is there an up or a down with that particular spring then?
this spring is uniformly uh, biased. If I look at the account at the number of um, active springs or active coils versus not, I don't know. Actually, that does look like, yeah, I have more active coils toward the bottom side. So yeah, that green would actually go down in this application here.
Right. Yep.
Yeah, so you can see that the tighter wind.
Yep.
But interesting, yeah. As you
It's
said, it looks like a barrel, but it's
it
a
does.
progressive round
Yep. Exactly.
variable rate spring.
Yep. Oh, super cool. So again, we can't emphasize, measure before you machine. Get, spring specs to match camshaft. That's important. And all of those specs that you get when you're, looking up a camshaft, especially flat tappet. Again, with all the flat tappet failures that are seen out there, it's just another recipe for disaster if you don't have the right spring pressure. So again, that's an important thing to check out when you're doing your homework for what valve train you're going to run in the engine.
Yeah, and you look at today, we have a lot of valve train that I have an intake and an exhaust intersecting, right? Uh, Dual overhead cam, hemispherical combustion chambers. Of course, you're going to see that. Like Harley, you even see that with the pistons. You have to be considering what pistons coming through the bottom, or else the pistons collide, right? Well, that's connected to a connecting rod and a crankshaft. Well, your valve train isn't. So if you have an unhappy valve train, you can have valves that are nipping each other and be trying to figure out what's going on with this engine. And, it's because the valve train's out of control. So you're going to see things that you could get by with years ago that you can't now. And again, when we're looking at variable rate springs and so forth, they may have started with 35 pounds on the seat to begin with. So what are we doing if we're tipping valve links and cutting the seats and stuff just to get it to match? So again, go back, take some measurements prior, and try not to deviate too far.
No, exactly. That's true. And I know a couple of times, and a lot of times when you're going to bigger springs, you're cutting valve pockets out and that kind of thing. And nothing worse than I've had this happen. You're hogging out a valve spring pocket and you hit water. And you're like, oh, some of the early stuff, the vintage stuff, 60s small block Chevy and that, back then we didn't have that kind of spring technology, so we had to go with bigger's better, right?
Right.
And then you get bit when you hit water and all that work is down the drain for
Yeah, we
sure.
always call it going swimming, and that's not the good kind.
Exactly. No, exactly. Well, Chuck, thank you for for putting that together for us and updating us on what's new and out there with the valve spring technology. For all our listeners, we thank you. We know you got take the time to listen to us and with the podcast, and you can always email us. We do have an email address. It's eppodcast@aera.org. If you ever have any questions or maybe valve spring related, if you want to reach Chuck, if you're not a member of ours, you're not on the tech line, you can still email us to that email address and we'll get back to you and answer those questions for you. So we're always looking for feedback. By all means, don't be afraid to email us. We can we're looking for topics and that kind of thing for future podcasts. And you can listen to the podcast on any of the podcast streaming services, as well as you'll find us on the AERA YouTube channel. So these are meant to listen to as well as to watch. So, Chuck, it's the same old saying, Next month we'll be at it again, and now we're back to the puzzle factory.
Back to the puzzle factory, Rob.
Well, till next month, Chuck, be cool.